Very much. Good afternoon there in India. It's a pleasure to be able to join you, even if only by video, and in a particular pleasure to be speaking alongside my good friend Mahindra Singhi, who has played a leadership role in the cement industry and more widely in arguing for a zero carbon economy. It's also a pleasure to be speaking at this meeting of the GCCA, which has emerged as a major force in arguing for high ambition in the cement and concrete industry, in particular through the 2050 climate ambition statement, which aims to deliver society with carbon neutral concrete by 2050. The challenge now is to work out how precisely to do that. And I know that the GCCA will be working over the next year to set out a clear roadmap. And it is also a major player in what is called the Mission Possible Partnership, a partnership between the World Economic Forum, the Energy Transition Commission, and several other organizations, about which my colleague, Faustine de la Salle, will talk tomorrow morning and talk specifically about the work which that partnership is doing in the cement and concrete industry. So this morning, what I will do is make some more general comments about the challenge of building a zero carbon economy across all sectors of the economy, but then place the cement and concrete industry within that. I speak as the chair of the Energy Transition Commission, which has already been said, is a coalition of major companies and experts, climate change and energy experts from across the world. It includes companies from Europe, from America, from China, and from India. For instance, in India, our members include Renew Power, Tata Group, and Dalmia Cement. We are all committed to the idea that the world must limit global warming to 1.5 degrees above pre-industrial levels, and that to do that, we need to achieve net zero emissions by around mid-century. And we say that that should mean net zero in every developed rich country by 2050 and in all developing economies by 2060 at the latest. And we are absolutely convinced that that is possible technologically and economically, and far easier to achieve than we dared believe just 10 years ago. And the fundamental reason for that rising confidence is the dramatic fall which we have seen in the cost of renewable energy over the last 10 years, with the cost of solar PV electricity generation down 90%, wind down 60%, and other key related technologies like batteries also down 85%. What that creates is an environment in which solar and wind is now the cheapest way to produce electricity. And we have seen that in India even more than in other countries, with the latest solar auctions producing solar PV electricity at just 2 rupees or 2.7 cents per kilowatt hour. The crucial question in power systems is now no longer how to generate cheap zero carbon electricity. We know how to do that. It is how to balance the system across the day, across the year, so as to balance intermittent supply from wind and solar with variable demand. But the good news is that we increasingly have the technologies and mechanisms to do that. And again, India has been a leader in that respect, with the remarkable result of a round-the-clock renewables auction earlier this autumn, at 3.8 cents per kilowatt hour, which was won by Renew Power. And when you take the possibility of using batteries to balance day to night, using hydrogen to balance across the year, forms of demand response, and other technologies of storage and flexibility, we are now absolutely clear that it is possible to build systems which are as much as 80 or 90% dependent on variable renewables, and to do so delivering electricity across the year at costs fully competitive with existing fossil fuel systems. And as we develop the ability to do that, we should then electrify as much of the economy as possible. And there are many sectors of the economy where it is relatively straightforward to electrify it, such as surface transport, where the future is undoubtedly electric. The internal combustion engine, as the head of Volvo Cars just said yesterday, is an old technology whose time has passed. We know how to electrify many sectors of the economy. And in many sectors, the costs to the economy and the cost to consumers will not only be nil, they will be negative. People will be able to buy their electricity, buy their electric cars, put fuel into their electric cars, i.e. electricity into their electric cars, at lower costs than they have to spend today on their fossil fuel-based cars. But while there are some sectors of the economy where the path to decarbonization is costless, indeed a negative cost, there are some other sectors of the economy which in the past we've called the hard to abate sectors, where it's a bit more difficult. These are sectors such as steel, cement and chemistry, and long distance sectors of transport such as aviation and shipping. But here too, there are routes forward towards a zero carbon economy by mid-century. And the Energy Transition Commission has set those out in our recent report, which is called Making Mission Possible. And again, in many sectors of the economy, in many of these sectors, these hard to abate sectors, electricity or hydrogen made from electricity has a major role to play. The future way to produce zero carbon steel, for instance, is almost certainly in the long term to use hydrogen as the direct reduction agent and to make that hydrogen from green electrolysis. And across all these sectors, there are ways towards a zero carbon economy. In cement too, and Mahendra has already mentioned this, both electricity and hydrogen made from electricity may have a role to play. We may be able to heat cement kilns directly with electricity or with hydrogen. But in cement, there are limits to the extent to which we can simply electrify or use hydrogen as the way to zero carbon economy. Because as we know, the very process of producing cement involves a chemical reaction where you start with calcium carbonate and you produce calcium oxide, and that is bound to produce CO2. And that means that for cement, we must look at a wide range of possible options. Bioenergy inputs may have a major role to play, and Mahendra has already spoken about the bamboo option, which enables us to actually have negative emissions as we pull oxygen out of the atmosphere. Carbon capture and storage, perhaps combined with bioenergy, may also be a key technology. And new cement chemistries, which reduce the CO2 amount, are also important. But it is also vitally important in the cement industry to look across the full value chain, which is why it is absolutely appropriate that you are the Global Cement and Concrete Association, because when one looks at that full value chain and right through to the building industry, there are other opportunities. There are opportunities in building to use concrete more efficiently and therefore less emissions by using less concrete in total. There are opportunities perhaps to use CO2 as the curing mechanism in cement, and that is the chemistry that Solidia are looking at. There are many options to think about trapping CO2 in the concrete or the aggregates, the carbonation options. There are multiple of these options, and I hope that the roadmap next year will set them out. As we drive innovation and technology, the costs of those options, whichever is the best, will reduce. But I suspect that unlike electricity production or surface transport, road transport, cement will always be a sector where there is some cost to achieving decarbonization. I don't think we'll get the cost down to nil. Indeed, that cost could be significant at the level of cement production itself. If, for instance, the cost of decarbonization is $100 per ton of CO2 saved, then that is going to add something like $100 to a ton of cement and $30 to a ton of concrete. And that will come down with innovation, but I think there will always be a cost. Now, at the level of the consumer and the builder of a house, an office block, or a bridge, that doesn't matter so much because the impact of that on the total end price of the end product will just be a few percent. And at the level of the economy, it will be offset by the fact that while people are paying a little bit more for their cement and their concrete and their buildings, they will be paying less for their cars and their road transport and their electricity. But it still means there's a cost to decarbonize, and that it means that if one company goes ahead with decarbonization and its competitors don't, it may face a competitive disadvantage. And so we will in cement, I think, have to debate not only the technological options to get us to decarbonization, but also the public policies that create a level playing field between those who are driving rapidly towards decarbonization and those who are not yet on that path. And that may require public policy regulation or carbon pricing or carbon taxation, which creates the incentives to get us there. So I hope that your roadmap will set out for India, for other countries, for the whole world, both a technological vision of how to deliver that promise of zero carbon concrete for society by 2050, but also the particular mix of public policies which is going to make that path inevitable and is going to create a level playing field between those who are doing the right thing and driving for that zero carbon future and anybody who is not going fast enough along that direction. Thank you very much, and I look forward to answering some questions.
Thank you, Lord Turner, for your enlightening address. I must say you have touched upon some of the various important aspects, like the availability of renewable energy is not an issue, but how to use it during the daytime, as well as how the companies can use it as a competitive advantage for decarbonizing their operations, and how to use more concrete more efficiently. There are a few questions I would like to ask. Uh, First is cement, as you know, is an intermediate product and it is not an end product. And it is always compared, cement is always compared with other building materials, which are actually the end products. So how should the cement sector take up actions which addresses this issue of not being an end product?
Well, one of the key implications of not being an end product is this point that it doesn't matter if, as a result of decarbonization, the product price goes up somewhat. For instance, we have this debate in the shipping industry as well. The shipping industry is now arguing for global action to drive decarbonization through the IMO, the International Maritime Organization, probably by the use of ammonia in shipping. And the assumption of the major container shipping companies, Maersk or Mediterranean Shipping Company or COSCO, is that that will add to the cost. But as long as they have a global regulation, which makes sure that they all have to do it simultaneously, that doesn't matter, because even if you increased freight rates, which is the intermediate product, by 50%, you would only increase the cost of a pair of jeans, say, made in Bangladesh and bought in London, by less than 1%. So we have to accept that we do have these intermediate products, freight shipping, steel, cement, which probably will be more expensive in a zero carbon economy, but at the level of the total economy, that is okay. But as I say, that does then raise the issue of how do you have the appropriate regulations and how do you have the appropriate carbon taxes or prices that create the incentives for everybody to head in that direction. The other thing to say, of course, is that cement is an intermediate product. It goes into a concrete, and then concrete in itself is an intermediate product. It isn't the end building. It's something that you build it out of. And that means the point I made earlier, that there is this huge opportunity to look at the whole value chain and to think about, well, how much cement do we have to put into an effective form of concrete, and how much concrete do we have to put into an effective building? And to be blunt, cement has been a sufficiently small percentage of the total end cost of the finished building that there has not been a very strong focus in the past on how do you minimize the cement into the concrete and how do we minimize the concrete into the building. But in an environment where we need to get to zero carbon, that total chain look at how do we think about the total efficiency of the system will be an important point for us to look at as well.
Thank you, sir. There's, if we may take one more question. For an hard to abate sector like cement and concrete, moving to a net zero may be possible by adoption of technologies like CCUS, electrification of kilns, etc. The current regulatory and market condition does not support these technologies in India and also in the globally. So as per you, what kind of changes will help in adoption of these technologies, predominantly in the cement sector?
Well, I think there are two issues in regulation. One is making sure that too conservative or slow-moving regulation does not get in the way of innovation. And I know from conversations of people in the cement industry that there is sometimes a feeling that the regulations as to what defines cement, what defines concrete, which of course in all countries is defined by building regulations because we need the safety characteristics, has sometimes been a bit conservative in responding to new cement chemistries, and where the regulation has been defined in terms of the cement chemistry required in the past to be safe, but has not realized that there are new ways of making an equally robust, strong, safe product. So we do need regulators to simply be building regulators to be equipped to move at speed to look at new regulation, new forms of cement chemistry, and make sure that they respond rapidly to any innovations rather than those processes taking many years to come through. I think, however, we also need to see regulation working in another way, which is to start saying you've got to use zero carbon cement and zero carbon concrete. So I hope that we will see regulations, for instance, in public procurement for business, demanding that the supply of their cement and their concrete is low carbon and eventually zero carbon. And we could see that both in the public procurement line for public purchase. We could see that with individual companies, private companies, demanding that in their supply chains. We know that a major driver, for instance, of renewable electricity has been the RE100, a club of major companies, all of whom make a public commitment to buy 100% renewable electricity. There is a EV100 club, companies which are committed only to buying electric vehicles. And we could also imagine a zero carbon cement club of companies which are committed to a zero carbon cement purchase. So I think there are a varieties of ways that we can either use public regulation or the power of purchasing to drive demand for zero carbon cement and zero carbon concrete.